Good morning, students. Am I audible? Okay, inform all to join, okay? Inform everyone to join. Uh, so this is a class of professional elective 1 of 6th semester. And that's what is the subject? It is a railway engineering, okay? So we are discussing about the third module, that is geometric design of a railway track. So we are nearly at the end of the module 3. So in the last class, so we have discussed about transient curve, right? And before that, we have discussing about uh, circular curve, fine. Then transient curve, okay. And also we have also discussed about super elevation, correct? So just for the revision, what is super elevation? Especially when it comes in railway track. So super elevation is that particular elevation uh, by which the outer rail of the track is raised with respect to the inner rail. I think this thing is clear to you. What is super elevation? If you still have some doubt, you can get back to me, or you can just go through a textbook. You will understand. Okay. So basically, super elevation is the uh, is basically define the height of the or elevation of the outer rail with respect to the inner rail. Okay, and the outer rail is raised with respect to inner rail to counteract the centrifugal force. Okay, when a train is moving along a curve, the centrifugal force will act in the CG of the train, and it will try to pull the train out of the track. Okay, fine. That means we have, for moving in a particular uh, um, circular track, or curved track, you have to maintain a certain speed. Okay, fine. And the particular superelevation is what? It is the height, elevated height of the outer outer rail with respect to inner rail. Okay, but along with that, to maintain the equilibrium superelevation, superelevation, or you can say that to maintain the equilibrium condition, or for safe movement of the train over this particular superelevation that is provided on the curve, a particular train has to maintain a certain amount of speed. Okay, so that is called saved speed of train. Okay, so what is saved speed? By definition, the saved speed for all practical purpose means a speed which is safe from the danger of overturning and derailment. That means, okay, first let me share my screen again. My screen is visible, right? So when a particular train is moving in a straight line, straight track like this, okay, suppose I'm drawing only one, and suddenly suppose there is a transition curve. It's coming from here, it is transition curve, and then finally it is circular, suppose, okay. But when a particular train is moving along this, a train moving along the straight track, it is a tendency to move straight, okay. But we have diverted the direction in this direction, diverted the movement of the train in this direction, but it has a tendency to move in this straight direction. So there is a possibility of derailment. Derailment means what? Because it will divert from the track. Okay, there is a possibility of derailment of the train, and if particular curved track is not designed properly, that means if the supervision is not provided uh, properly, there is a chance of derailment. That means a, overturning. Sorry, a train may overturn in this direction because of the centrifugal force. Okay, that means to counteract the centrifugal force, you can say it is centrifugal force, and to resist or to safeguard the train against derailment, you have to provide a superelevation, a desirable superelevation. Also, a safe. We have to maintain a safe speed of the train. Okay, you can just say it, safe speed. Sorry, or whatever. So we need to uh, maintain a safe speed. Fine. So basically, safe speed of the train, uh, it's deal with, or it's provided to save from the danger of overturning and derailment of the train. Okay, that means for safety purposes. And particular safe speed of a train, it's mainly depend on the gauge of the train. Gauge means, though, I think you already familiar with gauge, right? Suppose this is a uh, track. Okay, these are the sleeper and these are the rail. Okay, and I think you remember, right? The distance between the inner face of the rail, it is called gauge, right? For different gauge like broad gauge, for meter gauge or narrow gauge, the distance are different. Center to center distance between the inner face of the rail will be different. Fine. So the safe speed also depend on the type of the gauge, whether it is broad gauge, whether it is narrow gauge or meter gauge. Okay, and also radius of the curve. That means when it comes to curve, suppose this is a curve, there is a center will be there, or it is also depend on the radius of the curve. Okay, and also amount of the super elevation. What is the amount of super elevation? That means suppose this is your outer rail. The outer rail is how much elevated. Suppose I'm giving a cross section like that. In at the very curve point, suppose this is your uh, inner rail, this is your outer rail. Okay, so this amount of height is provided. That means the outer rail is raised about this elevation. This will be your super elevation. This amount is raised with respect to inner rail. So these things also matter. So safe speed of a particular train, depends on the gauge of the track, radius of the curve, and the amount of super elevation provided. Okay, clear? Okay. So basically, when it comes to safe speed, there's a standard formula, that is Martin's formula. It is familiar, very popular. Okay, so there is a Martin's formula who, as per Martin's formula, we have some pre-decided relation between speed of a train, that means safe speed of a train, with radius of the curve. Fine, this is fine. So correlating with the radius of the curve, we can derive the safe speed of the curve. Okay, so basically when it comes, the particular formula is divided in two parts. One is your whether the particular train is moving along the transition curve or non-transition curve, that is either than any curve other than transition curve. Fine. So, and also it is divided based on the type of the gauge also. As I already told you, safe speed depend on the gauge. Okay, gauge of the track or track gauge, and also depend on the radius. Fine. So here you can see safe speed of the curve. As per the Martin's formula, you can see for broad gauge and meter gauge, and for narrow gauge also there is different formula. Fine. Under broad gauge and meter gauge, there is again two formula. That is, you can see two part. One is your either a particular speed of the train on when the train is moving on the transition curve, and when the train is moving on the non-transition curve. That means the speed of the train may be vary depending on the curve, whether it is straight, whether circular or transition. If train is moving along the transition curve, then particular train have to maintain this speed. And if the particular track is broad gauge and narrow gauge, broad gauge and meter gauge, then only. And what is the formula? V is equal to 4.4 root over R minus 70, where V is your speed in kilometer per hour. Fine. And R is the radius in meter. Fine. This unit also very important. Fine. V is in kilometer per hour and radius is in meter. Fine. And when it comes to non-transition curve, okay, under this broad gauge and meter gauge, that particular safe speed will be 4 by 5th 4/5 of the speed calculated using this equation. That means whatever value you will get for transition curve, that means the value of the safe speed on transition curve, it the 4/5 of that particular value uh, will be the safe speed of the train when moving along a non-transition curve. Clear? Similarly, we have a different formula for narrow gauge. For narrow gauge, under narrow gauge, we have two type of from equation for safe speed of the safe speed of train on curve. One is a transition curve and non-transition curve. Here you can see v is equal to 3.65 multiplied in root over r minus 6. Okay, r is a similar unit and v is also the same unit, but particular value should not be more than 50 kilometer per hour. It is the maximum value. Fine. If particular this v comes higher than 50, then we'll adopt 50 only, because the particular on transition car, when it comes to narrow gauge, there's maximum speed should not cross 50 kilometer per hour. Okay, then it will not be going to save. Fine, it is fine. Okay, and for non-transition car, it is this equation, and here the maximum speed is 40 kilometer per hour. Fine. So this is the formula which is proposed by this Martins. Okay, it is also known as Martin's formula. Okay, but the Indian Railway no longer follows this concept of safe speed on curve. Fine, but this is are the basics formula. What I am giving you, because you should know, that's why I'm giving this particular formula, and it is known as Martin's formula. But currently, Indian standard doesn't follow this formula. We have modified this particular formula. Fine. Okay, let's go to that particular formula of safe speed that is accepted by Indians or adopted by Indian Railway. Okay, okay. So new formula for determining maximum permissible speed on transition curve that we're going to discuss now. So earlier, the Martin's formula was used to work out the maximum permissible speed or safe speed on curve. That is, that we have already discussed this formula, which is proposed by the Martin's form. Okay, known as a Martin's formula. This Martin's formula was used to work out the maximum permissible speed or safe speed on curve. Fine. This empirical formula has been changed by adopting a formula based on theoretical consideration as per the recommendation of the Committee of Directors, Chief Engineers, and the ACRS. So you just find out what is ACRS by Google. Okay, it's up to you. It's your homework, like kind of thing. Okay, so ACRS, find out. So the maximum speed for transition curves is now determined as per the revised formula given below. So the particular formula has been revised, the Martin formula, this Martin's formula has been revised and a new formula has been proposed and adopted by the Indian Railway. And they are for broad gauge, for meter gauge, and for narrow gauge are different formula is given here. You can see. Now, in this particular formula, mainly in previously there is only safe speed of the train is related to the radius of the curve only. Okay. Now, in the new formula, which is adopted by the Indian Railway, in this particular formula, the safe speed of the, or you can say the maximum permissible speed of a train is related not only with radius, it's also related to the super elevation. That's I already told you, right? Previously, the safe speed of a train or maximum permissible speed of the train depend on the gauge track, okay, or track gauge, radius of the curve, and super elevation. Fine. So here you can see all three factors are considered here. See, for different gauge, we have different formula. That is, first point is justified. Then it is related to radius and also related to super elevation. Now, regarding in this formula, you can see V is equal to CA plus CD multiply by R divided by 13.76 and whole root over. And this can be simplified by this formula also. 0.27 multiply root over CA plus CD whole multiplied by R. In this particular formula, V is the maximum speed in kilometer per hour. CA actually what? It is actually cant. Cant means super elevation. Same thing, don't confuse, okay? It is sometimes called as cant or sometimes super elevation, okay? So C8 is the actual cant which is applied in the field, actual cant, okay? But by definition, okay? That is the raised of the outer rail with respect to inner rail, fine? In millimeter, the unit is in millimeter, fine? CD is what? CD is the permitted cant efficiency in millimeter. Now, regarding cant efficiency, we have already discussed in the last class. What is the cant efficiency? That is, if along a particular train, along a particular track, okay, if a particular train is moving with a speed higher than the safe speed, that means higher than the permissible speed. That means there is a deficiency in the super elevation. Okay, that means whatever the super elevation provided in the field, and that particular super elevation is related to some safe speed, okay, or permissible speed of the train. And if a particular train is moving along the same track but with the higher speed, uh, more than the safe speed, you can say, then you can say there is a lack of super elevation. That is called cant deficiency. Okay, that means we have a cant deficiency in that particular case. So this is also uh, measured in millimeter only. This is also a super elevation, but it is actually cant efficiency, okay, in millimeter. And R is radius in meter, okay. So don't confuse in unit. R in meter here, fine. And this equation is derived from the equation whatever I just leave it this teacher, okay. So and it is based on the assumption that G is 1750 millimeter. You know, the for broad gauge, the what is the gauge length is what? What is the gauge? G equal to 1750 millimeter. It is standard, which is the center to center distance between the rail head of the broad gauge, having 52 kg rails. It is the weight of the rail. Fine. So basically, you should remember the gauge of different track. Okay, like whether it is broad gauge, whether it is meter gauge, all these things. Okay, for different gauges, the center to center distance between the rail will be different. Clear? Okay. So this is the equation for broad gauge. Now for meter gauge, this is the equation. V is equal to 0.347 root over CA plus CD whole multiplied by R, where R is the radius, same, everything is same. Only what is the difference here? This is based on the assumption that the center to center distance between the rail head of the meter gauge track is 1058 millimeter, which is standard. Okay. Okay. So this is to for more broad gauge, this is meter gauge, and this is for narrow gauge. Okay, for narrow gauge specifically for this gauge having 762 millimeter. Okay. For narrow gauge, this is the equation. That is equation for permissible speed, maximum permissible speed over a transition curve. V is equal to 3.65 multiply root over r minus 6. But also it should not be more than 50 kilometer per hour. It is also be taken in consideration. This value should not be more than 50 kilometer per hour. Okay, so this is all about your safe speed or maximum permissible speed over a transition curve or non-transition curve. Okay, and we have already discussed about different formula accepted by Indian standard. Okay, now let's discuss about some maximum permissible speed. Okay, so till now we have discussed about uh, safe speed. So almost similar is that. So basically, the maximum permissible speed on a curve. How to decide? How to decide a maximum permissible speed on curve? So basically, the maximum permissible speed on curve is the minimum value of the speed that is calculated after determining the four different speed limit mentioned here. Okay, that means there is a four condition. There are four factors. Based on that particular different four factor, we have to decide we need to first fix the speed of the train. And from that particular four value of the speed, we have to add up the minimum value of that from four formulae or four condition. Okay. What are the four condition? First one we need to consider this one, the maximum sanction speed of the train. Okay, speed of the train over a section. This is the first condition. Then maximum speed of the speed of the train, taking in consideration of the can deficiency. Then third one, maximum speed taking into consideration of the speed of the goods train or can access. And finally, speed corresponding to the length of the transition curve. Okay, so based on these four factors, first we need to find out the speed of the train, and after finding this speed of the train based on these four conditions, we need to find out which one giving the smallest value. That one will be your small permissible speed. Okay, so maximum permissible speed on the curve will be determined after these four different speed limit mentioned. So what are the speed limits are there? The first speed limit is based on this maximum sanction speed of the section. So what is this? So this is the maximum permissible speed authorized by the Commissioner of the Railway Safety. This is determined after an analysis of the condition of the track and the standard of the interlocking, the type of the locomotive, and the rolling stock used and other such factors. So overall, based on the condition, type of the railway track, based on the type of the locomotive, type of the rolling stock, that means the combination of locomotive and the wagon, based on the interlocking, that means we are going to discuss in the next model what is interlocking, fine, means the crossing and point and crossing basically, fine, and other condition of the track. Based on that, the commissioner of railway decide a particular amount of speed of a train over a section. That is will be your denoted by maximum sanction speed of the section. Okay. Next, okay. So next condition, the maximum speed of the section, taking into consideration of can deficiency. But that means considering that can deficiency, or you can say consider the super elevation, uh, deficiency, we can also derive one equation for value of. We can find out the value of maximum permissible speed of the train. How can we? Let's discuss here. First, we need to find out equilibrium speed of the train. That means just the minimum speed that required for the safe movement of the train. That first we need to find out. The equilibrium speed is decided after taking various factors into consideration and the equilibrium super elevation calculated. So based on equilibrium speed, first After that, we need to find out equilibrium super elevation. Okay, by the standard formula of super elevation that we have already discussed in the last class. Okay, we also discussed how super elevation can be determined. We already explained, or we already derived the equation. Okay, just go through the previous notes. Okay, so by deciding the equilibrium speed of a train, we need to find out first the equilibrium super elevation. That is the minimum super elevation that is required for the safe movement of the train, which is provided in the curve. After that, the can deficiency is added. That means how much additional can deficiency can be provided. Not provided actually, can be adjustable, you can say. The can deficiency is then added to the equilibrium super elevation, and the maximum speed is calculated as per this increased super elevation, that is CA plus CD. So it is a reverse calculation. What do we do actually? It is a reverse calculation. That means first we find out that's equilibrium super elevation based on the equilibrium speed. Then we decide a certain amount of can deficiency and just sum it up with the equilibrium super elevation. This is CA is what? CA is your equilibrium super elevation that is actually provided. And can deficiency is a probability that the can be go excess. Okay, that is actually defined as a can deficiency. Now, if I sum it up, this CA and CD, it will be our new super elevation, which is not exactly actually provided. The existing one is your CA super elevation, but CD is basically depend on the maximum speed of the train. That's why we have added here. Fine. So based on the CA plus CD, we can derive the maximum speed of the train. So like this, we can also find out another speed of the train based on this super elevation and can deficiency. Fine. Next, number 3, taking into consideration of the speed of the goods train or can access. That means based on the lowest speed of the train also we can also find out. That means lowest, you can say based on the speed of the goods. That means they are moving in the slow movement, right? That's why based on that we can also find out I make a permissible maximum speed of the train. Okay, that means a cant is calculated based on the speed of the slow moving traffic. That means first of all, this super elevation CA, which is provided on the track actually, it is find out by considering the speed of the slowest moving traffic. That means like goods train, they move very slow like that. Okay, the speed of the slow moving traffic. That means you are providing a very less amount of can for that. This speed is decided for each section after taking various factors into account, but generally the value is 65 km per hour for broad gauge and 50 km per hour for meter gauge. Okay, that means the speed of the train, the speed of the slow moving traffic, which is considering goods train, and the speed of the train is considered as what? Basically 65 km per hour and 50 km per hour. This is a standard one, fine. And based on that, first find out the cant. Okay, that is a super elevation. Okay, actual super elevation, fine. After that, the maximum value of the can axis. That means since on existing super elevation, the train is moving in the lowest speed. That means we have a extra super elevation, isn't it? So we have a excess of super elevation. That means we have a can axis. The maximum value of the can axis is added to this can, and it should be ensured that the can for the maximum speed does not exceed the value of the sum of the actual can and the can axis. Fine. That means I first find out the actual can based on the slowest moving train, the speed of the slowest moving train. Okay, fine. First find out CA. Then now we need to find out the maximum speed considering the natural one. Okay, so if you want to find out the actual speed of the train, then we have to add can access with the can actual. Okay, and based on this CAN plus CE, based on this super elevation, you need to find out the maximum speed of the train. Okay, so this number 3 is little bit just opposite of this C2. In this second condition we have added can deficiency. In the third case we added can access with the actual can. Fine. And third one, when there is a transition, the length of the transition curve is not available, we can also find out a safe speed or maximum permissible speed on transition curve. So this is the least value of speed calculated after taking into consideration of the various length of the transition curve given by the formula listed in the table 13.6. So I'll show you this particular table. So this table represents a length of transition curve. Fine. And from based on this length of transition curve, we can go for finding the speed of the train, maximum speed of the train based on the length of the transition curve. And the length of transition curve can be derived from this table. Okay. So there are different conditions are given, that is criteria for length of transition curve. Okay. That means there are two criteria of rate of change of can along the transition curve. If the rate of change of can, that is already mentioned in the previous class, rate of change of can means the variation of superelevation with respect to time. Okay. So rate of change of superelevation or can, if it is taken as 35 millimeter per second, that means and each second per second 35 millimeter changes in super elevation for a normal case and 55 millimeter per second for exceptional case. In this particular scenario, in this particular condition, the desirable length of transition curve is 0.008 ca multiplied vm. Okay. Okay. And what is vm here? Vm is a maximum permissible speed. Maximum permissible speed in kilometer per hour. And cd is what? Cd is your can deficiency. Somewhere it is cd. Yeah. In the second case, here you can see this mainly CD is also applied here. When the rate of change of can deficiency is taken as 35 millimeter per second for normal case, and for exceptional cases 55 millimeter per second. Okay, then we have used this formula for length of transition curve. Okay, this is the desirable length and this is the minimum length. Okay, this is the for kind of your information for that. Just you can know this particular thing. Fine. This is the relation, and this CD can be determined by this equation. Even in this equation, CA can be determined by this equation. Simple as that. Okay. So this is all about your maximum permissible speed. Fine. Maximum permissible speed on a particular section of a railway track on curve, which is decided based on these four criteria. This first, second, third, and fourth. Right. So I'll give you one explanation for a numerical. From the numerical, you will really it become easy to understand. Okay, wait a second. Okay. Okay, I'll just show you a particular numerical, and after that you just go through by yourself. Again, if you want, I can also explain in the next class. So quickly, now this is our numerical. Fine. So in this particular numerical, you are asked to find out and to calculate the super elevation. You need to find out the super elevation and the maximum permissible speed of the train for a 2-degree broad gauge transition curve. That means the degree of the curve of the degree of the transition curve is given as 2 degree on a high speed route with a maximum sanction speed of 110 kilometer per hour. Okay, about maximum sanction speed is we have uh, um, already mentioned, right? That's the commissioner have decided this particular sanction speed of the train based on overall track condition and the type of the locomotive. Okay, so as per the sanction and as per the uh, competent authority, the sanction speed of the train is decided as 110 km per hour, 110 km per hour over this 2-degree broad gauge transition curve, and you need to find out the super elevation and the maximum permissible speed. Okay, the speed for calculating the equilibrium super elevation as decided by the chief engineer is 80 km per hour. Okay, so the equilibrium super elevation as decided by the chief engineer is 80 km per hour. So equilibrium super elevation is given to you, and a book speed of the good train. The speed of the good train is also given here, 50 km per hour. Fine. So these values are given to you based on this given data. You have to find out the super elevation and maximum permissible speed. Clear? So let's find out for super elevation first. And before going in the super elevation, what is the we need to first know what is the equation for super elevation. I think you remember the equation of super elevation, v square by 127 or something like that. Is there not? Isn't it? So in this particular super elevation, to find out the super elevation, you need to first find out the radius of the curve. Okay. Now, to find out the radius of the curve, how can you find out? The degree of the curve is given to you, and you know the relation between degree of the curve and radius of the curve. So by the correlating the degree of the curve with the radius of the curve, we can first find out the radius of the curve, and using this radius of the curve, we can first find out the equilibrium superrelation first. Okay, how? This one. So first you find out the radius of the curve, and this is the standard formula that you have to remember first for broad gauge. Okay, since it is mentioned here, it is broad gauge. So for broad gauge, it is 1750 for d divided by d, where d is what? D is your degree. Okay, just put the value here and just find out the value of radius of the curve in meter. So r will be your 875 meter. Okay, after getting the value of radius of the curve, you can find out the equilibrium super elevation, or you can say super elevation for equilibrium speed. Fine. Equilibrium super elevation equilibrium speed, that means super elevation for equilibrium speed. And how can you find out? Gv square by 127 r, where g is your what? It is your track gauge. And for a broad gauge, what is the track gauge? It is 1750 millimeter standard center distance between 252 kg rail. Okay, so this is standard. You have to remember this gauge length for broad gauge. Okay, 1750 millimeter. And speed of the train, basically what is 80 actually? It is the equilibrium speed, equilibrium super elevation. That means speed, the speed for calculating the equilibrium super elevation is decided by the chief engineer is 80 km per hour. Since we are finding equilibrium super elevation, then you have to use this value, 80. Okay, v here is 80 km per hour, and r is the radius we have already determined. Put all value, you find out the equilibrium super elevation as 100.8 millimeter. This is the equilibrium super elevation. Fine. Now, super elevation for maximum sanction speed, we need to find out. Okay, that means this is the minimum super elevation or equilibrium super elevation, that is 100.8 millimeter. Okay, now you can see here maximum speed sanction is how much? The maximum sanction speed is 110 kilometer per hour. Okay, that means we have some can deficiency. Okay, there is a maximum speed is how much? 110 kilometer per hour. For considering this speed, let's find out super elevation considering this maximum sanction speed. Same equation, gv square by 127 r. In this particular formula, g will be same track. Okay, but speed we are considering 110. Okay, here you can see 110 for considering maximum sanction speed. Okay, and radius will be same. As you can see, radius will be same, only speed is different. Now how much you will get? 190.6 millimeter. That means if you consider maximum speed of the train, how much super elevation coming? 190.6 millimeter. If you consider equilibrium speed, equilibrium speed means how much? 80 kilometer. We are getting 100.8. That means for lowest speed of the train, we are getting smallest value of super elevation. If you increase the velocity, increase the speed of the train, you are increasing the super elevation. Okay, so that means there is a can deficiency. This is the super elevation. This is the minimum super elevation that can be applicable or for safety. Equilibrium one. Now the actual, or you can say the superevolution for maximum sanction speed is coming as 190.6 millimeter. Now it is more than the equilibrium superevolution. Then that means we have a CAN deficiency. So that means here you can see CAN deficiency will be how much? 190.6 minus 100.8. How much? It is 89.8 millimeter. Okay. And there is also a permissible one, that is which is less than 100 millimeter, hence permissible. So that particular CAN deficiency also there is a limit. It should be more than 100 millimeter. Okay. If it cross 100, then you have to put 100 only. It should not be more than 100. Okay. Next, we can also find out superevolution based on this your different condition, like superevolution for goods train with book speed of 50. Okay, that means we have a different condition also given here, no? That is book train speed is given as 50 kilometer. Now considering this speed also, we can find out the superevolution. The superevolution for goods train with the booked speed of 50 kilometer per hour using the same formula, same value, only difference is your speed of the train will be different. Okay, now putting 50 here, you will get this value. Now you can say, now we see, now it's coming as 39.4 millimeter. Your equilibrium superevolution is how much? 100 millimeter, 100.8 millimeter. Okay. Now, if you are reducing the speed from 80 to 50, your superevolution also get lower. Now, what do we have? We have an excess of CAN. Okay, since this particular superevolution for goods train is less than the superevolution for equilibrium, we have an excess. We have excess of CAN. So, what is the CAN excess? The original one, that is 100.8 minus this value, is 39.4. How much? 61.4 millimeter is CAN excess, and which is less than 75 millimeter, hence permissible. So there is a permissible limit of 75 millimeter. Okay. So this all about your superevolution. Different superevolution can be determined. This is your superevolution considering equilibrium speed. Now second one, superevolution considering the maximum sanction speed. Next, superevolution for goods train. From this uh, value, we can find out CAN deficiency also, CAN excess also. Okay, fine. So the maximum, now next we need to find out the maximum speed of the, what do we need to find out? Calculate superevolution and maximum permissible speed. Fine. So we need to find out maximum permissible speed of the train on a curve, and we know the formula. This V is equal to this formula. Now we have already mentioned here, as per Indian Railway, for broad gauge, it adopted this formula. Either you can use this one or this one. So in this formula, we have already derived what is the value of CA, CAN efficiency. Sorry, CAN deficient. Actual CAN is 100.8. This is the actual CAN. 100.8 millimeter is actual CAN. Fine. CD, CAN deficiency is 89.8. Okay, and what is the radius of the curve? Is 875 millimeter. Okay. So using this formula, you just find out the speed of the train, maximum speed of the train. Okay. Now, after getting this maximum speed of the train from this formula, the maximum permissible speed on the curve is least of the following. The maximum sanction speed, which is given in the question, it is 110 km per hour. Maximum or safe speed over the curve based on a theoretical consideration is how much? We have got 110.1 km per hour. And also there is no constraint on the speed due to the transition curve length. So therefore, the maximum permissible speed over the curve is 110 km per hour, and this is the maximum permissible speed we will consider, because it is the minimum of this one. Okay, that means we need to compare which one is smaller, whether it maximum speed, sanction speed, or whether the speed we are finding from this formula. Okay, we need to consider the lowest one, that is 100 km per hour, and corresponding superevolution, we need to consider the actual superevolution that we provided. So corresponding to the 110 km per hour speed of the train, the superevolution we provided is 100.8 meter. Okay, that is your 100.8 meter. Fine. Okay. So we are taking this 100.8 millimeter superevolution for this particular trait. So this is a complete numerical of superevolution. Go through this particular numerical, and if you still have confusion, you can come to me. Okay, with this I just want to close my sharing because I don't have much time. We need to make it quick. Fine. Okay, let me take a snap of your attendance. Let's quickly wait. Is there any doubt, anyone? If you don't have any doubt, first let me close my recording so that I can take your attendance. Okay.